Hi dear friends, welcome to Oil and Gas Training. Here is another video from Oil and Gas Training, Separator Operation Part 2. Welcome to this video. Separation Process Part 2. Section 1 we have discussed about basic definition, type of separator, separator principle, operation principle, and design parameters, construction details, etc. etc. And in this one we are discussing about various internal different type of internals using for accelerating better separation and control system, safeguard system, and startup and shutdown and troubleshooting, etc. Welcome to this video. Internal devices are used in production separators to improve separation efficiency, accelerate the separation process, reduce the size of vessel, reduce the cost of the vessel. See, internals are basically a helper, so mechanical helper you can say. Different type of helpers are using in oil and gas operation. Thermal helpers are there, like thick crude oil is using heating before entering the separator to reduce the viscosity and improve the separation process. And sometimes chemical helpers are there. What is chemical helpers? De-emulsifier. So thick emulsions are there sometime in the different type of crude oil with a thick emulsion. So de-emulsifying agents are using, emulsifiers are using to break the emulsion. So that is a chemical helper. So this is another helper, mechanical helper, calling separator internal parts. So it will improve the efficiency, accelerate the separation process, so reduce the size of vessel, reduce the cost of vessel. Inlet deflector plate or baffle. As the inlet stream strikes the plate, the liquid falls to the bottom and the gas flows around the plate. So see, the different pictures are showing here. So mixtures are entering in various inlet. So different type of inlet deflector plates based on the characteristics and design of the separator, feed rate, velocity, temperature, etc. Composition of the crude oil, various type of inlet mixes are using. So inlet baffle plate is strike the plate, the liquid falls the bottom. So the first stage separations take place here because the reducing the velocity, change the direction. So gravitational separation take place in using the help of this inlet deflector plate. Straightening vanes are positioned in the gas section of the vessel to produce smooth laminar flow of the gas stream. So to make the flow steady state condition, to avoid turbidity or turbulence, this is straightening vanes are using in the next to inlet deflector plate. The mist extractor is positioned after the straightening vanes to remove liquid mist from the gas stream. The mist extractor provides a large surface area to the mist droplet to coalesce, means join together. So this is usually keeping just after the straightening vanes, or sometimes look like a wire mesh. It is keeping to the gas outlet before gas leaving to the separator. So all liquid droplet, small liquid droplet collecting together, coalesce or join together, becoming or large droplet and release from the gas stream and getting down to the liquid surface. Vortex breaker is another type of separator internals are positioned just above all liquid outlet. They prevent vortexes from forming and so stop other phases living with the liquid. So it will keep the maintaining a proper level in the liquid section. So all liquid not making sudden drop out the liquid level. It will keep maintain a level and maintaining a smooth flow in the liquid line. So the picture is clearly explained the half cut picture showing the various internals. Some of them we discussed, some of them not discussed. It's a typical example for how the internals are arranged in the separator. So you all please working in the site, or if any chance getting when opening a separator, just to go and visit how it is. It will be a good experience. So inlet deflector is there, foam breaker is there, that is straightening vanes is there, or straightening device another one is there, mist extractor is there, and another type of weir is there, vortex breaker is there, coiler is there. So inlet distribution baffles are there. So where it is these all internals to depend, it will change or it will separately different type of internals are using in different separator, not unique. According to the situation, characteristics, flow stream, properties, based on that one, internals can also change a little bit. Normally a float shield is positioned so that it protects the level controller internal float or displays from the liquid wave action. So normally liquid maintain, if the liquid is not maintaining a smooth level, float or a displacer cannot read properly. So that is float shield will maintain inside the separator. Or weir also, a weir is a vertical baffle. A vertical plate is used to three-phase separation to separate oil and water, and it helps control the liquid levels in the separator. So these are just to see in the picture shown here. Separator control system. Controls are important to all process equipment to make sure each equipment works safely and efficiently. Control system controls the important process variables with a set point to achieve the best operating value. Some of you are maybe very much aware or experienced in control system, or maybe some of you are very beginners, or we will in future, in the coming slides, we were taking basic instrumentation and control or various instrumentation using in oil field operations or various equipment. So once you, now it is maybe difficult to understand what is control system and instrumentation. So just to wait for few of the slides and you will get more idea on in the later stage. The important process variables in separator are pressure and level. Any process equipment is working in oil and field always controlling based on the process variables. Main four important process variables are pressure, level, temperature and flow. There are many other variables are there, but most commonly we are using these four, and most of the time we try to control these four process variables to maintain or work a safe and efficient manner in the process equipment. Same like in separator is the important two process variables are pressure and level. So pressure is we have to control the pressure of the gas. In many reasons are there that we will discuss later, and the pressure is controlled by a pressure control valve. Not only pressure control valve, it's a control loop that we will explain later. And in the figure it is showing that there is a one valve is there near the gas outlet. You can see that one. That valve is a PCV, and the gas outlet, outlet, the liquid level is controlled by a LCV. In the bottom side, in the oil side, you can see one valve is there, that is called LCV. Separator control system, need to explain some more slides. So number one is a pressure controlled loop. In the loop there will be a pressure gauge or a pressure sensor, pressure transmitter, that is in the picture it is showing PT2, and a pressure indicator controller that is showing it is a PIC. Then the signal is that dotted line is showing the electronic or pneumatic signal. That signal is going to PCV. Here in the picture it is PCV1. So that is the pressure controlled loop. Pressure sensor, pressure transmitter, pressure controller and pressure control valve. Same like in the oil level, if you look at the right bottom side of the oil side, so you can see the LT here, LT1 or LT3, that is 1 or 2 they are giving for the better reading or accuracy, and the LIC is a level indicator controller, and the LCV is the level controlled valve. Same like in the water side also you can see LT, LIC and LCV. For better understanding, some of the other names are showing here in the short form. I can just to give, and it is better to understand the full name of that one. Shutdown SDV is the shutdown valve, that is the inlet line shutdown valve. Then BDV is the blow down valve in the gas outlet, and PCV is the pressure controlled valve, it is in the gas outlet, and LCV is the level controlled valve either in water outlet line and oil outlet line. PAC is the pressure indicator controller, that is a controller using in the maintain the set point, and LIC is the level indicator controller. These all control system we will discuss in detail in our coming slides. Another important area is to discuss is safeguard system. Safeguard systems are the important part of any type of process plant and equipments which operate the plant safe and efficient level. Safeguards activates alarms and provide an automatic shutdown of the all inlet and blow down all gas outlet in any abnormal condition. It's a safeguarding system to protect the equipment, operator and environment. Safeguard system protect personnel, plant and environment from abnormal operation condition. What are the abnormal operation condition? Maybe the pressure high, pressure low, level high, level low, temperature high, temperature low, high vibration or gas leak or a fire or instrumentation pressure low. Various examples are there. One by one we will discuss that one. Examples of safeguard systems are shutdown valves and different alarms and switches. Safeguard systems in separators. One is pressure switch high. Separator is operating with very high pressure. In any abnormality condition is downstream pressure can get a high or low, or upstream pressure before the separator can get from the wellhead upstream area. Separator pressure can go or in the line pressure or inlet pressure can go high or low. In both conditions can create a dangerous condition. So we have to protect our vessels, operators and personnels and the environment. So here it is a pressure switch high. So with a marking, it is a number 1 is showing that is a pressure switch high. It is connected into gas outlet line. That is in the top of the right top of the line, that is a gas outlet line. That pressure switch high is connected, is a pressure switch. So that is the dotted line is a signal. That signal is going to a safeguarding system. That is a logic, instrumentation logic. From that logic is another signal is going to a valve in the inlet line. There is that called ESD valve. So there is a set point is there pressure. Suppose it is operating at a 150 psi. So the high pressure may be in 200 psi or 175 psi. If the pressure crossing 170 psi or above or just 170 psi, the safeguarding pressure switch high will activate and that signal will go to safeguarding system, and the result will be that inlet PSV, inlet SDV will trip. So the separator will be in safe condition. Immediately another ESD is there in the gas outlet line just after the pressure switch high. That will be maybe in open condition or any shutdown happen, it will be in open, it will go to open mode. So the separator inside some pressure is there, that pressure will release to flare line. Same like pressure switch low is there, that is that it didn't show in the picture. Most of the cases that also will connected to in the outlet or inlet. Another safeguard systems in separators are one a level switch low and high in both in oil side and water side. In the picture, it is a demonstration purpose only we are using this picture. So it is look like a typical P&ID drawing. So the dotted lines are instrumentation signal or electrical signal, and continuous line is the flow line. So level switch low is show marking in the picture is 1, marking as a 1. So when the level is low, if we need to protect it, if the liquid level goes to low level, below a set point level, high pressure gas goes to downstream low pressure vessel, which can create many operating problems. To protect from these abnormal condition, level switch low will activate a shutdown logic. So this low pressure, low level will create a lot of subsequent problems. So to avoid that one, the logic will provide a set point. So when it is reaching the set point, it will automatically cut or shut down the inlet and close the outlet liquid line valve. Sometime it will open the ESD gas line BDV, or sometime it will not open according to the logic. And simultaneously, similarly, level switch high also, that is a marking in number 2 in the picture. Level switch high will protect the separator from liquid level high, and this may leads, if the liquid level is going high, what will happen, it will carry over with the gas, which can make operating problems in downstream scrubber or compressor. Some of the other important safeguard systems are instrument pressure low and fire and gas detection system. Many others are there that we'll study in coming slides. These systems are also activate a shutdown logic in any case of abnormality. That is the safeguarding system logic is shown in the figure. That is the instrumentation logic or electrical logic, you can say. All shutdown logic will force to close the inlet shutdown valves. Here in the picture it is ESD valve. In the inlet line, that is the red line, there is a valve is there in the red line, continuous line. Open BDV in gas outlet, that is in the ESD valve is in the gas outlet line, and close LCV or SDV in the liquid outlet. So these are in general, but for getting more experience, if possible, to read an P&ID from your working stations, a P&ID, and understand from the P&ID what are the various safeguarding system or control system using in any of the vessels, and what are the safeguards, how the shutdown logic is connected. Separator operation. With the separator in normal services, the following checks should be made. Here we will give some basic idea. One is observe the various level, pressure, temperature and flow control instruments to see that they are controlling with the proper desired ranges to maintain the safe and efficient operational parameters. Diaphragm operator control valves should be stroked occasionally to see that they will fully open or close without restriction. 3. Gauge glasses should be dried and cleaned occasionally to prevent buildup of scale and debris in the lines. Buildup of scale and debris in the line could cause false readings. 4. The pressure drop across a demister pad and other coalescing devices should be monitored for an increase, which indicate a buildup of solids and the need to clean or replace the devices. Troubleshooting of separators. A process elimination finds the cause of an operating problem. Each event which can cause the problem is checked until the cause is found. The proper sequence of checking the various causes is to eliminate the easy one first. These are instruments, pressure gauge, control valve position, controller output pressures, gauge glasses, flow meters, etc. So various instruments malfunctioning. In making these checks, be sure that the instruments are working properly and not giving any or a false reading. Once the easy cases are checked and eliminated, the more difficult causes are checked. Another important part of troubleshooting is that of maintaining an overall view of the total process and not just the troublesome equipment. Problems at the front end of the plant often show up at the back end. Find the source of the problem before attempting to fix it. Thank you for watching this video. Please subscribe this channel for timely updation and information. Definitely we will update more videos on oil and gas operation and other details. Thanks for watching.